So welcome back, Abafundi. So what if I said to you cos pen, cos book minus sine pen, sine book? I'm hoping you would say that is cos of pen plus book. Or if I said to you 1 minus 2 sine squared book, that you would say that's cos of 2 books. All right. Or if I said to you cos squared pen minus sine squared pen, you would say, that is cos of 2 pens. Okay, right, let's dive back in and let's go and practice using these new identities now. So here we've got one straight up, cos squared of 26 minus sine squared of 26. That will just be the cos of 2 lots of 26. Okay, in fact, it will be the cos of 52 degrees. Right, now if you haven't tried these, let's pause the video, try them, okay, and see how you go, and then let it play again. So do all the questions on this page. Some of them are not quite what we're expecting. In other words, they're missing something and we might need to make a bit of an adjustment. Try them and then let's see how you go. Okay, so now we've got 2 cos squared 20 minus 1. Well, that is cos of 2 lots of 20. And cos of 2 lots of 20 is exactly the same as cos of 40. Okay, the next one, 2 sine squared 8 minus 1. Now that's not the right way around. Our double angle formula for cos is 1 minus 2 sine squared. So in fact we could write this like this. We could factor out a negative. Now inside the bracket we've got exactly the right form for cos of 2 lots of 8. So the final answer is negative cos of 2 lots of 8, and 2 lots of 8 obviously is 16 degrees. So our final answer for this one is negative cos 16 degrees. Okay, let's look at the next one. The next one is 2 sine half theta cos half theta. Now that is the right hand side of our double angle formula for sine. So it will be sine of 2 lots of the angle in question. And that's why we use books and pens and things, because it doesn't matter what's inside there. It'll just be sine of 2 things is 2 sine thing cos thing. Okay, so in fact this is actually just sine of theta. The next one, what does it kind of look like? It kind of looks like the one above, all right, but it's not quite right. Okay, it hasn't got a 2 in front. Could we put a 2 in front? We could put a 2 in front if we put a half in front as well. So we're hoping that you can see that this is exactly the same as half, 2 sine 6 degrees cos 6 degrees. And that there is a pattern or a formula that you need to recognize, that 2 sine 6 cos 6. Okay, that is half, the half is the half that we took out, that is half sine of 2 lots of 6 or sine of 12 degrees. Okay, right, the next one, 2 sine 22,5 cos 22,5. Right, this one for the first time we're actually now going to get something that we should know how to calculate. We're going to get sine of 2 lots of 22.5. And 2 lots of 22.5 is actually 45. So this is now sine of 45 degrees, and we would expect you to be able to do that with or without a calculator. Without a calculator, either using the special triangles or the fan that we showed you, but the answer is root 2 over 2. Okay, sine squared 15 minus cos squared 15. Now that's familiar, but it's not quite the right way around. That's actually the negative of cos squared 15 minus sine squared 15. Okay, and that is cos squared minus sine squared is our double angle formula for cos. So that's actually the negative of cos of 2 lots of 15. It's the negative cos of 30 degrees, and cos of 30 degrees is root 3 over 2. Okay, we could check that answer right from the beginning with our calculator. In other words, we could work out all of that on a calculator and we'd get exactly that. The next one, let's expand that. So let's multiply it out. And what we get is we get cos squared 15 we get 2 lots of sine 15 cos 15. And then we get sine squared 15. Okay, and so what we're going to end up with here is, remember that cos squared plus sine squared is just 1. Okay, so cos squared plus sine squared is 1. So in fact, this piece and this piece just come to 1. But what about 2 sine 15 cos 15? What about this thing? This we should recognize. All right, absolutely. That is the double angle formula for sine. That is sine of 2 lots of 15. That is in fact sine of 30 degrees. Plus the other one, the one comes from the 2 yellow bits. And sine of 30 is a special angle, so it's a half plus 1. Final answer, 1 and a half. Okay, now on the next page, we're going to ask you to try these. We're going to ask you to pause the video and try them without a calculator. And then in fact, we're going to ask you to try this whole page on page 143. Pause it, see how you go, and then we'll go over them. Okay, so 1 minus 2 sine squared, well, that's exactly sine of 2 lots of 15. Sine of 2 lots of 15 is sine of 30, and so we get sine of 30, and sine of 30 is a special angle. Sine of 30 degrees is a half. Okay. Right, the next one, 2 sine 15 cos 15. Well, that's the double angle formula for, sorry guys, I've made a horrible mistake here. All right, that is not the double angle formula for sine. Okay, that is in fact the double angle formula for cos. I hope you picked up on my error there. Okay, so that's cos, and then in fact that is root 3 over 2. This is the double angle formula for sine, and this is equal to sine of 2 lots of 15. And sine of 2 lots of 15 is the same as sine of 30, and the same sine of 30 is exactly the same as a half. So sine 30 degrees equals a half. And as we've said, you can check these answers on a calculator. Even though you need to do them, you can check them on a calculator. The next one is exactly our double angle formula for cos. So this is going to be cos of 2 lots of 22 and a half. All right, and that is in fact going to be cos of 45 degrees, and that's a special angle. Cos of 45 degrees is root 2 over 2. Okay. Right. Next one says simplify without a calculator, and this is where it starts to get a little bit interesting. The top is obvious and easy because there's only one, there's only one one double angle formula for sine. That's 2 sine theta cos theta. Now, on the bottom, we've got 1 plus cos 2 theta. We need to think now, because for cos 2 theta, we've got 3 possible double angle identities. All right, and there's one that makes a lot of sense to use, and the one that we're going to use has got a minus 1 in. And the reason it's helpful to have the minus 1 is it will cancel out with that there. So we are changing our cos 2 theta to 2 cos squared theta minus 1. Just to help you understand what we've done here, we have changed, all right, we've changed this for this. Okay, now the minus 1's cancel out. Okay, so what we're going to now get is we're going to get 2 sine theta cos theta over 2 cos squared theta. Okay, 2 sine theta cos theta. Sorry, my computer's just playing up a little bit here. Won't give me a pen again. Okay, so we get 2 sine theta cos theta. And on the bottom we've got 2 cos squared theta. I'm going to write that as 2 cos theta cos theta. That will help us see that in fact what we can do now is we can divide out. We're not cancelling. The 1 and the minus 1 cancelled to give us 0. That's cancelling. Here we are dividing cos theta and cos theta. They're both going once. We're dividing 2 and 2, they're both going once. And we end up with sine theta over cos theta. If we stop there, we wouldn't get all the marks because we expect you to know that sine theta over cos theta is exactly the same as tan theta. Okay, now this simplified nicely, but it only simplified nicely because we made the right choice of our double angle formula for cos. And we're going to get more into that a little bit later. Now we move on to these questions, the likes of which we've seen before, whereby we are told about the sine of 8, and we're now asked a whole lot of other questions. Right, the cos of 8, firstly. Okay, remember how we can get from sine to cos. There are actually two ways. The safest and kind of best way is to draw a little triangle. Okay, so we're just going to draw, let me just try and draw this nice and neatly for us. Okay, we're going to draw in our set of axes. Okay. Right. And we've got an 8-degree angle here. Right. And then we've got sine of 8 is m. So m is the y value over the r value. This x value by Pythagoras will be the square root of 1 squared minus m squared. Right, remember we can't square root those two things separately. You can't separate this, because of the minus sign, you can't just separate that out. Right, but cos of 8 we can now easily get. Cos of 8 is going to be our x value over our r value. It's just going to be 1 minus m squared over 1, which is just 1 minus m squared. Okay, cos of 100. Right, cos of 100, well, that's a reduction idea. Remember, all sine, tan, cos. Okay, all sine, tan, cos. So we're in quadrant 2, and cos is in fact negative in quadrant 2, but we are 10 degrees. So cos of 100. Okay, cos of 100 is, yeah, I think this. Okay, we'll cos of 100 is, I think this question should not be here. All right, I don't think we can get to the answer for this one. So let's leave that one for now. Let's look at cos of 344. All right, we're in quadrant 4 by 16 degrees. This is going to be exactly the same as cos of 360 minus 16. And cos of 360 minus 16 is exactly the same as cos of 16, quadrant 4 for horizontal axis. Now 16 is double 8, so we can change this to cos of 2 lots of 8. All right, now we need to pick one of our double angle formulas, and the most obvious one is the one that only involves sine. Okay, and so we're going to use the one that says 1 minus 2 sine squared of 8. All right, but we know that sine of 8 is m, so our final answer here is 1 minus 2m squared. Right, we like these questions because they test understanding, and they test that we know how to do this without a calculator. Okay, sine of 196. Well, sine of 196, we're in quadrant 2, quadrant 3 by 16 degrees. This is going to be negative sine of 16 degrees. Now, sine of 16 is actually sine of 2 lots of 8 degrees. So in fact, this is going to be negative 2 sine 8 cos 8. We're using our double angle formula for sine. Sine of 8 we know is m, so this is going to be negative 2m. And cos of 8 we know is the square root of 1 minus m squared. And there we have it. Okay, right. Okay, so we also can generate what are called half angle formulae, right? Because if we put a half, remember cos of 2 alpha is cos squared alpha minus sine squared alpha. If we just halve that and halve these, we get these formulae. Right, so let's dive straight in and look at how we can use these to do exercise 2 on this page, okay, page 144. So we know about 32 degrees. So let's see what we can do here in terms of using the 32 degrees. Cos 212, we're in quadrant 3 So cos is negative. And at 212, we are 30 degrees away from the horizontal axis. We're actually 180 plus 30. So negative cos 32 degrees. Okay? But that's just negative g. Right, the next one, cos 116. All right, now where is 116? Well, 116 is in fact, let's see where 116 is. 116 is actually 64 degrees away from a horizontal axis. All right, this is the same as cos of 180 minus 64. Now 64, you might say, what's important about 64? 64 is double 32. So this will be negative cos of 64 or negative cos of 2 lots of 32. We know about cos of 32, so let's use our formula that involves only cos squared. So cos of 2 lots of 32 will be 2 cos squared 32 minus 1. But remember, there's a minus in front of all of this, so in fact it's going to look like that. And our final answer for this one is going to be negative g squared, sorry, negative 2g squared plus 1. Okay, right, tan of 212, well, that's quite straightforward. We're in quadrant 3 by 32 degrees. That's going to be exactly the same as tan of 32 degrees. To do this one, ideally we need a little sketch. I'm actually going to pop that little sketch up here, and we're going to see what it looks like. Right, so we've got something like that. Okay, we've got a 32 degree angle over here, and cos is x over r. So in fact, this is the square root of 1 minus g squared. 1 squared minus g squared. Okay, and so tan of 32 will just be the y value over the x value. It will be the square root of 1 minus g squared over g. Okay, sine of 196. Well, 196, we're actually in quadrant 3 by 16 degrees. This is going to be the same as the negative of sine of 16 degrees. Okay, now sine of 16 is actually half of 16 is actually half of 32 degrees. Right? So let's just try and think about how we could do this now. Right? We know that cos of 32 is cos of 2 lots of 16. So we know, and I'm going to write this in here with a blue pen. Okay, just up top here. We know that cos of 32, and I want to use my formula that only involves sine. Cos of 32 is going to be 1 minus 2 sine squared 16. Okay, so, but we also know that cos of 32 is g. So in fact, 2 sine, if I add 2 sine squared 16 to both sides, and I subtract the cos of 32, which is g, I'm going to get that. So I know that 2 sine squared 16 is 1 minus g. This is going to allow me to solve for sine of 16. I would divide both sides by 2, and then I would square root both sides. So in fact, sine of 16 is actually going to be 1 minus g over 2, all square rooted. Okay, now just for the sine of 16, when we square root, we could have plus or minus, but sine of 16 we know is positive, right? So in fact, it will be positive, but then we've got that negative that was there already. Okay, that's a little tricky, but not too bad. Okay, sine of 302. Let's work out where we are at 302. Right, which quadrant are we in? Well, we're actually in quadrant 4 by 32 degrees. This is actually the sine of 270 plus 32. And that will be in quadrant 4. Sine is negative in quadrant 4. So it's actually going to be negative cos of 32. And we know what cos of 32 is. We know it's g. So final answer, negative g. Okay, and the last one, cos of 376. Well, which quadrant are we in? We're actually back in quadrant 1 by 16 degrees. Cos of 376 is exactly the same as cos of 16 degrees. Okay, now we're going to do exactly what we did with the blue pen up there. I'm going to come and do the same thing down here. I've got a little bit more space this time. All right, we know that cos of 32, which is g, we know that's the same as 2 cos squared 16 minus 1. Okay, and I want cos of 16. So all I'm doing now is solving this equation for g. Let's add 1 to both sides. G plus 1 is 2 cos squared 16. All right, let's square root both sides. Let's divide both sides by 2 rather. G plus 1 over 2 will be cos squared 16. So in fact, our answer here, if we carry on from here, instead of that, we're going to write the positive square root of that. It will be the positive square root because cos of 16 is a quadrant 1 angle, and that's positive. So there's our final answer. Right. So the stuff in blue, all right, is not equal to cos 16. It's the working to generate an expression for cos of 16. Right. Now we've shown you how to do one of those. Before the next lesson, please try the next question, all right, on page 145. Try all of those, and we'll look forward to going over it with you next time.